Let me please make me the host.
1 second, 1 second.
Hey guys, very good evening everyone and welcome to today's session by 360DigiTMG. We have been discussing about cybersecurity analytics in this domain analytics program, which we have been discussing from the last week. And today on the final day of this domain analytics, we are going to discuss about neural networks. We will be also discussing about MLP, that is your multi-layer perceptron. All these things we'll be discussing today. MLP will also be discussed. So when I say that neural network, what is the first thing that comes to your mind? What is meant by the neural network? Neural network, guys, is a computer architecture in which a number of processes are connected together in a manner suggestive of the connections between neurons, like in a human brain, and which is able to learn by a process of trial and error. Okay, that is a general definition of your neural network. So yeah, today's agenda is neural network primer, perceptron and multi-layer perceptron algorithms, activation function, error surface, and gradient descent algorithm. All these things will be learned. So if I were to say that, give me an example of neural network, what would that be? When we talk about examples of various types of neural networks, there is Hopfield network. Then there is the multi-layer perceptron. There is Boltzmann machine. Then we have Cohen network. All these are your example of neural network. What are the components of neural network if you talk about? There are three components of neural network. The first component or the main component we could say is the input layer. Second is a processing layer. The third one is your output layer. These are the components of neural network. Talking about the features, what are the features of neural network? First one that I would say is your speed. Second one, first one I would say is speed, and second one is your processing. Talking about speed, when I say speed, what I mean to say is that it is very faster in processing your information. Response time over here in neural network is in nanoseconds. Just like the human brain, we respond in matter of seconds. We respond in the same way in the neural network. The speed is very good. When we talk about processing, it is nothing but a serial processing. This is what it does. Size and complexity. What I mean to say by this is that it is having a very small size and very less complexity as well. It does not perform complex pattern recognition tasks. Today, we are going to discuss basically about MLP, that is your multi-layer perceptron, MLP. Even before we go to MLP, let me discuss all these other things, that what are the use in cybersecurity. We can say that we can use neural network in intrusion prevention system, spam filtration, next generation firewall, fake news detection, and many other things. And this is how, as I told you, neural network is nothing but, we are trying to mimic the human brain, and this is how it is being done. The information, these are the dendrites from the cell body. The information is taken. This is the nucleus axon. It is passed through your axon terminal. We were talking about input layers, hidden layers, output layer. This is what I was told. This is the components, 3 components I was telling. Right. And this is how we mimic the human brain. We take the information from the dendrite, the input signal, we pass it through a post-synaptic signal, cell body, and then we have our output signal. This is how we are trying to mimic the human brain. Okay. And this is our neural network panel. Neural network, as I told you, is a machine learning model which is inspired by your, network of biological. Mimic means copying. Sangini. Sangini, the mimic means copying. We are copying whatever human brain does, we are copying that. I hope it is clear now. Sangini. Neural network, guys, is a machine learning model inspired by the network of biological neurons found in our brain. 3 types: artificial neural network, MLP or multi-layer perceptron, what we say. Convolutional neural network, CNN, recurrent neural network, that is your RN. The human brain, guys, is made up of 85 billion neurons, resulting in a network capable of representing tremendous amount of noise. For instance, a cat has roughly 1 billion neurons. A mouse has about 75 million neurons, and a cockroach has only about 500,000 neurons. In contrast, many ANN contain far fewer neurons, typically only several hundred. So we are in no danger of creating an artificial brain anytime in the near future. Okay, people are very much scared these days that we might end up creating an artificial human brain, because we are having only around 85 billion neurons in our human brain. But when we talk about computer terms, when we talk about ANN, then we are only having several hundred of these neurons. So there is no way that we can make or end up creating a artificial brain. Even when this laboratory was created called as CERN, where they were trying to find out the God particles. Even before it started, people were so much scared, and there was so much taboo associated with it, right? People were trying to, say that, okay, the world is going to end, this and that. No, nothing like that. So in this way, also, we are not going to create the human brain, right? Today, we'll be discussing more about your multi-layer perceptron, also called as the artificial neural network. Okay, moving ahead. And this is your perceptron algorithm. What it says is, the perceptron algorithm is a 2-class binary classification machine learning algorithm. Okay, before coming to that, let me quickly give you the idea about what an MLP is. MLP, guys, when we say multi-layer perceptron. Now, this is a supplement of feed-forward neural network, guys, and it consists of three layers. We saw that, one is input layer, output layer, and your hidden layer. What happens over input layer is, what is happening over here? The input layer receives the input signals to be processed. The required tasks such as, if I were to say prediction and classification, that is performed by output layer. By this figure, you can make out. Now, an arbitrary number of hidden layers that are placed in between the input and the output layer are two computational engines of your MLP. Similar to a feed-forward network in MLP, the data flows in the forward direction. See here, data is flowing in the forward direction. Okay. That is from your input to the output layer. The neurons in the MLP are trained with the back propagation learning algorithm. MLPs are also designed to approximate any continuous function and can solve problems which are not linearly separable. The major cause or major use cases of MLP, you can say that is your pattern classification, recognition, prediction, and approximation as well. Okay. Now your multi-layer perceptron. Now this model that work as a universal approximator, that is, they can approximate any continuous function. For instance, they can be used as SEE models. SEE models. MLPs are composed of what? Neurons and perceptions. Okay, this is what we are knowing about it. The input feature, what happens is passed on to a input function, which computes the weight sum of your input feature. The result of this computation is that it is then passed, processed to your activation function. Say F is your activation function. Here you are seeing the weighted input. This is the output. And activation function is given, which will produce the output of the perceptron. This is how the things are working in your MLP. When we talk about MLP, learning in MLP, you can say it also consists of, in adjusting the perceptron weight so as to provide low error on the training data. And this is basically done using the back propagation algorithm, which attempts to minimize your MSE. However, these algorithms can also be used in, all these algorithms, these can be also used. Strategies are also used to avoid overfitting the training data. That is to, avoid creating models that have poor predictive performance due to the modeling random error or your noise present in the training data. All these things are there. Again, when we talk about this, we can also use our MLP in verbal sentiment analysis. Whatever we are talking about, what is the sentiment? We analyze that also. This is an example where we can use our MLP. Okay. Other example, I would say a fully connected, or if I were to say in other words, a fully connected multi-layer perceptron is nothing but a multi-layer neural network connected fully. That is it. It is having three layers we discussed. One is hidden layer. If it is having more than one hidden layer, it is called as your VANN. And this MLP is an example of nothing but your feed-forward artificial neural network. If we talk about, stock analysis, if we are talking about, say, image identification, If we talk about spam detection, if we are talking about election voting prediction, all these are the places or the instances where your MLP can use. Okay, and then we have something called as the MLP classifier. What is this? MLP classifier stands for multi-layer perceptron classifier, which in name itself connects to a neural network. What happens over here is like, unlike other classification algorithms, such as your support vectors or your naive-based classifiers, MLP classifier relies on underlying neural network to perform a task of your classification. So here we have this perceptron algorithm in two classes. That is, you can say binary classification, machine learning algorithm. The building blocks of the neural networks are what? We understood that it is your neurons, weight, and activation function. It is having a single node or neuron that takes a row of data as input and predicts a class label. Neurons have weighted input here, threshold values, activation function over here, and an output. This is achieved by calculating the weight of the sum of the input and a bias that is set to 1. The weighted sum of the input of the model is called what? Activation. And the formula for calculating your activation is nothing but your weights into input plus bias. Now, after you calculate your activation, if it is above 0, it means the model will output 1.0. If not, then it will going to give the output as 0.0. Here is the prediction 1 and prediction. Now, as the inputs are multiplied by your model coefficient, in case of linear regression and logistic regression, normalization and standardization of data prior to using this model will be having your most successful approach. This is how your perceptron algorithm works. And again, here we have some various formulas for creating our randomly initializing the weight vector. And we keep on repeating it till when? Until the error is less than a threshold or your maximum iteration. For training each example, what we need to do? We need to predict output using what? Current network weight. And we have to update those weight vector by using this formula. This is nothing but your learning rate, and this is where we are calculating the error. This is how we are doing a perceptron algorithm, or this is how your perceptron algorithm works. All these are there. We have seen that, we were talking about neurons, like the way brain is working, the same way our MLP works using the neurons. Here we have, something which was proposed by McCullough and Pitts in 1943. They have showed how the neuron works, or how are the things in neuron. We have this figure. We have the integration function over here. These are nothing but aggregating your input signals. We have a threshold logic over here. That is your activation function. And we are getting an output. Here you are getting all your input. All these are your input that is being fed. There is a threshold which determines, what is the activation function, and then you get your output. And this is something which was proposed by McCullough and Pitts about your MP neuron. Yeah, MLP. MLP, guys, multi-layer perceptron, as I was telling you, is the supplement of feed-forward neural network. It consists of 3 layers. We talked about this. Input layer, what it is doing? It is receiving the input signal to be processed. The way brain, the required task, such as prediction and classification, is performed by your output layer. We see something, we observe something. Then we predict something or we classify something. This is mimicking the human brain. Yeah, sorry for that. So this is mimicking your human brain. Number of hidden layers that are placed in between the input and the output layer. They are true computational engine in your MLP. Getting the point, guys? Just a moment. Okay. Yeah. Talking about one more important thing, when we say that we are having input layer, output layer, hidden layer. Input layer, we know whatever we are observing. Output layer, we know whether we are going to predict or classify. What is hidden layer? What happens over in the hidden layer is, hidden layers, guys, it allows the function of a neural network to be broken. Broken down into what? To be broken down into a specific transformation of data. A specific transformation of data. This is what is happening in the hidden. Okay, what happens in hidden layer? It allows for the function of a neural network to be broken down into a specific transformation of the data. Each hidden layer is specialized to produce a defined output. Defined output. Okay. When we talk about MLP, the standard MLP is a cascade of nothing but your single layer perceptrons only. This is a layer of, again, input nodes, a layer of output nodes, and one or more intermediate layers. The interior layers are nothing but your hidden layers. These intermediate layers, what I'm talking about, or your interior layers, these are only your hidden layers. Because they are not directly observable from the system's input and as well as the output. That is why they are called as the hidden layers. Activation function. Activation function, guys, what it does is it decides whether a neuron should be activated or not by calculating the weight sum or further adding bias with it. The purpose of the activation function is to introduce non-linearity into the output of a neuron. And this is how, you know, our error surface looks like. A central theme in the neural network research is to find the right network, that is the architecture and learning algorithm for a problem. Cost of the weight function, bias, everything is. This is how your error function looks like. Now, then we have gradient descent algorithm. Gradient descent algorithm is nothing but, you know, it is an interactive first order optimization algorithm which is used to find a local maximum or minimum of a given. This method is commonly used in machine learning and deep learning to minimize what? Cost or the loss function, that is nothing but your linear regression. That is where we are using our gradient descent. Okay. So this was all I wanted to discuss about my neural network file. Now I have my Jupyter notebook open for you. And here what I'm doing is I'm doing my fake news detection over here. I've used an open source uh, data which was easily available in the open source. I have used that, and It is nothing but a very interesting thing which happened in the recent years. It was Donald Trump and Hillary Clinton feud, right? A lot of fake news things were also getting, circulated during the presidential candidature. So I thought this would be an interesting topic to discuss today, and I'm trying to use my neural network to further look into all my analysis or to do my analysis. I'm using neural network. So I've also used word cloud, which is showing us various graphical representations and all these things. Yeah. So coming back, I have imported warning. I have imported, ignore and all these warnings are there. All the important libraries needed, NumPy, Pandas, Matplotlib, Keyboard, NLTK, word cloud I have imported. I've imported tokenizer also. Why tokenizer? Because we are going to tokenize the word. Right. Maybe what happens in the news, we have a sentence. In order to analyze it, we have to tokenize each word. So I have imported my tokenizer also. I have imported my part sequence from TensorFlow. I have imported my sequentials. I have imported embedding, LSTM, and maxful 1D. I have imported test script. I have imported your accuracy score classification record. All these I think I have imported. Then I have imported my data set, which is an open source data set. And if I say take.head, all these things are which I am seeing. Donald Trump sends out embarrassing new year. And this is the title, the text it is having. Donald Trump just couldn't wish all Americans, and the date is there. Drunk bagging Trump, Stafford's rapid Russian, House Intelligence Committee Chairman, all these things when you say take.head. Then I have started counting the subjects. And for that, what I did was I have said for P count in take.subject.value dot ITER items. Print ST count and I got the total load. If I say take.shape, it is giving me new. All these parameters are got. So here news 9050, politics it was 6841, left news, government news, this, all these things are shown. Now I have tried to use a graphical representation over here, and all this information which I have got, I have tried to put it up into a bar chart for the easy visualization. Data is equal to fake plt.show sns.convert. Here I have initialized the parameters. All the same information is given over here in this. Now I have also tried to initialize my word cloud. This is going to give me much more, better graphical representation. Here again, I have initialized my parameters, say for text, for word news and fake test.value, all these parameters are there. For the word cloud, I have initialized what is the width, what is the height, what is the background color. The stop words I have taken from nltk.corpus. We know that generate text, figure size, all these things I have given over. And here, this kind of figure is what we are doing. Donald Trump and Hillary Clinton like also featured, said, even Trump, Obama, Republican, and all these things are given. You can easily make up from these that which words have been used more for spreading the fake news kind of thing. Now, once the fake news thing is detected, we are trying to explore the real news. I've imported another data set which was easily available in the open source. Again, when I've said head, it is giving me all these information. And when I am seeing over here, what is the difference in the text I'm observing? Most of the text contains Reuters information such as Washington. See over here. Some texts are nothing but a tweet from your Twitter. Few texts do not contain any publication in it. Right? All these things are there. Then I have started cleaning the data by first creating a list of indexes that do not have publication part, because here we are saying that few texts do not contain any publication info. So I've done that as an unknown publisher. I have tried to initialize the parameter. Say for index row in enumerate real.text.value, try record is equal to row.split. I have taken this value, max split I have kept the one. So what happens is if no text is present, following will give an error, record one. But if length in publication part is greater than 260, following will give error ensuring no text having this in between its counted, right? So I have used assert over here. I have taken the length record 0 is smaller than 260 except unknown publisher dot append and index. This is what I have done. Again, what I'm trying to do over here, I'm trying to create a list of index that is having no publication info, right? So here, this is what I am doing, and then we are having a list of indices over here which are having no publication info. See, all this is what we want. Yeah, and while doing this, what happened was, when we were doing this, what I noticed was test at the index 8970 is totally empty. See here, it is totally empty. This part. This is total empty. So what happens is, again, I am trying to do real.ilog. Here I am taking the index location 8970. Why? Because it is having no place, no data over here. So I am saying I will be removing title, Supreme Court, roundup, and all these things I have done, name 870, and this is 7. Now, once we have these information regarding, the text which is having not any publication info. So here I'm trying to do the separation of that publication info from the actual text what we are having. Initializing publisher tmp underscore text. Here I am initializing my function for index row in enumerate real.text.value. If index is unknown publisher, it is not going to find out because we have already seen that. Add unknown publisher not mentioned. This is what I've done. tmp dot underscore text dot append row publisher dot append unknown continue. All this is what I have done. Here, what I am doing, basically, I am trying to separate the publication info from what? From the actual text. Then again, I am replacing the text column with nothing but a new text by adding separate column for the publication info. For doing that, all these parameters are initialized. Real publisher is equal to publisher. Real text is equal to tmp underscore text. The year publisher tmp, all these things are there. And when I say real dot head, it is giving us top 5 values. Now here, if you see, publisher column has been added. Previously, it was not there. But now your publisher info is added. How we have segregated this publisher info based on 2 words. One was your Washington and Reuters, right? Based on 2 words, we were able to do this particular segregation. Now, what I'm doing is I'm checking for rows with empty text. Like over here, we were having in 8 numbers, line number 8970. In the same way, I'm trying to find out my empty information. So here I am saying index for index, text and enumerate real.text, all these things I am seeing. And when I am running this, it gives me only 8970. That is right. We were having only one. Now, when it is having no data in it, what we are going to do? We are going to drop it. I have dropped it. And now what I am doing over here, I am checking for the same in the page. So here I have initialized the parameter empty underscore take underscore index, index for index, text and enumerate, take dot text dot values, all these things I have done. And now when we will run this, this is what we are getting. So what is happening over here? A lot of capital cases, you can see all these are the capital cases. Now, what happens is put preserve case of letters. But what we are doing, we are using Google's pre-trained word to vectors later on, which has will form lowercase words. Now, what we are going to do, since we are having a lot of this kind of scenario, where capital letters are offering, so we are going to convert it into your lower. Okay, so I have done something like that over there. Now here what is happening, I'm looking for the publication information, checking if some part of the text has been included, such as your publisher info, and nothing I can find over here. Nothing as this sort is available over here. Now I'm getting the total row. For that, again, real shape I'm going to say and counting the subject. And total records I got to 21,416. Political news is 11,271 and world news is 10,145. I have implemented the same in the box plot, and you can say that we are having more numbers of political news when compared to your world news. Then what I have done is I have tried to make a word cloud for the same, and these are all the things. Political news you can see in the bold figures, White House, Prime Minister, Donald Trump, Donald President, all these things. Using all these parameters for the real news, I have tried to make. Now I am trying to process it. What I am doing, I am adding class information, real and fake. Yeah, we want to do fake news detection, real and fake. We are combining the title. Then what I am doing, I am trying to find out that is the subject different from the real or the fake. And if there is a difference, we are going to drop it. There is no need. We only need either real or fake. That is it. If the subject is different or it is not fulfilling either one of the criteria, there is no use of keeping it. So we have to drop. Coming to this point, I have used this particular topic or variable. For the real, I have used subject, date, title, publisher. For the fake, subject, date, title. If there is no publisher, obviously it means that it is an anonymous news. Anonymous, right? And the anonymous news, mostly it is your fake news. So this is how we are trying to differentiate it. Combining both in a data frame over here using the append function. Now I am downloading it. If not downloaded in the local machine, then this is how you can do. I have removed the stop words, punctuations, and single character words over here. We can see, and then I have done the vectorization. So what I have done is I have created my word to vector model using Genset. And here I am giving the dimensions to the vectors, that this is going to be the dimensions, obviously. And these are the vectors which has been created. Say here we have the sample word for the corona. So for that, I have created all these vectors. Here you can see all these are the various vectors we have created. Say for Facebook, these are the vectors. Say for FPI, these are the vectors. For Iran, these are the vectors which are created. Tehran, if it comes into our real or the fake news. Iranian, if it comes to the fake news or the real news. Destabilizing, Hezbollah, nuclear, Riyadh. All these are the words which could, we could be having into the corpus of our real or fake news data. So in order to analyze it, I have initialized various vectors for each word over here. And this is going to help us find out whether it is a real or a fake news. All in the same way. Now I have started tokenizing over here. Tokenization, tokenizer is equal to tokenizer, and all these things I have done. Then I'm checking. Let's check the first 10 words of the first news. Every word has been represented with a number. See, vectorization. Now what will happen? Let's check the word for the numerical representation. That is, mapping is preserved in dictionary, word index, property of English. All these things. Now see over here. From is your 1. Said 2. President 3. Would 4. People 5. 1. 6. This is nothing but your mapping. And this mapping is done into your dictionary. And dictionary is nothing but your word index property of your equation. Right? We can pass numerical representation of words into neural network. Yeah, that is the reason behind what we are doing over here. We can pass too many, sequence to word model of RNN, as we have word in use as input and output. That is probability of being real. Yeah, real of it. For many to one model, let us have a fixed size input. For determining the size input, what I am doing over here, I am making a histogram. Over here, for no words in use, shows that most news articles are under 700. And here I am keeping each news small and truncating all news to 700 while tokenizing, only till 700. By seeing this, we can say that it is heavily skewed. If you were to draw the inferences, excuse me, heavily skewed. There are news with 5,000 words. Let us truncate the outliers. Yeah, it is having the outliers also. Let us do that. So again, here what I'm doing, I'm saying nos.np.array, all these things. So what happens over here is that out of the 48,000 news, 44,000 of the news is having less than your 700 words. Then what is happening over here? I'm trying to keep all the news to 700 words, and I'm adding padding to the news, which is having, less than 700 words, and truncating the long one. So this is what I am doing over here. Max length I've taken as 700, which is what we have decided. 700 words. Right? Making all use of maximum length defined above. Padding sequence I've added, and I've given maximum length is equal to max length, which is nothing but 700. All news that are having 700 words, if they had less words or they had been padded with 0, this is what is happening. That is, 0 is not associated to any word, as mapping of the word is starting from where? From 0. 0 will also be used later if unknown word is encountered in the test data. Output, if we run this, we are going to get 700. Length x0, yeah, 700. Adding 1 because of the reserved 0 index. We all know in Python, indexing starts from 0, whereas in RStudio, it starts from 1. So now, if in Python, the indexing is starting from 0, so I'm adding 1 over here because of this reserved 0 index. Also, I'm embedding layer by creating one or more vectors for unknown words or padded words. This vector is filled with zeros over here. So what is going to our vocabulary size is going to be? It is going to be nothing but your tokenizer.word underscore index plus. Then I'm trying to create a function for weight matrix for word to vector Jensen model. This is what I have done. We created a matrix for mapping between word index and vector. We are using this as weights in embedding layer. Embedding layer accepts your numerical token of word and output corresponding vector to inner layer. It sends vector to zeros to the next layer, so on and so forth. Here I am getting my embedding vectors from the word to vector and using these as your weight for non-trainable Keras embedding layer. Here I am defining my neural network. I am saying model is needed to be sequential. Here what I am doing, I am taking our non-trainable embedding layer, initializing the parameters, model.add, all these things I have done over here. Then I have used LSTM over here, initialize the parameter, and see this is the kind of model what I am getting. Layer embedding LSTM density output shape is given over here. Parameters is given over here. Total parameters is this. Trainable parameters is this. Non-trainable parameters is everything we got. Everything we got. If we are trained on the, we are training and testing and splitting the data. For that we have, and we fit that data using model fit. This is what we are getting. Training on to 23,570 samples. And we are validating on 10,102 samples today. And prediction again is happening today. We are checking the prediction of news being real. So converting into classes. Class 0 is fake if predicted probability less than 0.5. Else class 1. Class 1 is what? It is real. So here we are seeing class 0 is having the precision of 0.9. Recall is 0.9. F1 is 4 is 0.9. All these things are accuracy 0.99, 11,224. Macros, all these things are given. 0 again, this is denoting what? This is denoting your fake news. And 1 is denoting what? This is denoting your real. By this, you can easily identify which news was fake news or which news was your real. So guys, this is how I have used my neural network for the fake news detection and fake news screening thing. I hope you guys liked this session a lot. So yeah, thank you so much guys for joining. Once again, I would like you guys to thank you so much for attending this domain analytics session. This is where we are going to end this session for today. Thank you so much guys for joining. Have a wonderful learning and be safe, keep on practicing. Thank you so much guys.
Sir, did you share this codes to us?
No, not yet, not yet. I have your email IDs with me. Today is the last day, so tomorrow everyone will be getting that in your mail ID. Tomorrow by the end of the day project. Okay.
Okay, sir. Thank you.
And yeah, one more thing, guys. I hope everyone is added in the group. If not, if you want additional help, you can message in the group, Telegram group, or let me show you guys my number. This is my number, or I'm giving in the chat window. You people can save my number and connect with me anytime. I shared my number in the chat window. You people can connect with me over there. In case of doubts or whatever the things may be, you can connect with me. Okay. So thank you so much guys for joining. Have a wonderful evening, everyone. Bye bye.